Hello everyone and welcome to the next session of our webinar Würth Elektronik. My name is Silas and I will moderate this webinar today. The topic of the day is digital isolators, the next step in signal protection. Our speaker today is Artem Belyakov. Artem, hello, welcome, hi. Cool to have you here. He is working at Würth Elektronik and he will hold the presentation and then he will answer your questions. Before we start with the webinar, I would like to give you some more information. You will be muted during this webinar. This means that you cannot ask us questions via your microphone, but you have the opportunity to ask your questions into the chat. The presentations will be about 30 minutes long, and then after that we make a short Q&A session, and then Artem will answer your questions. If we are unable to answer all your questions within this time, Artem will answer it via email in the next days. So now, last information from my side. You will all receive the link to the presentation as well as to the recording in the next days. So now I will hand over to you, Artem, and I wish you an exciting webinar.
Thank you so much, Silas, for introduction. Dear colleagues, as already Silas said, the main topic of this webinar, digital isolators, the next step in signal protection. Digital isolators are the best solution for galvanic isolation for digital signals in high-speed application. This is a very important task for almost all area of electronics, especially for different types of interfaces, for example, SPI, RS, I2C, CAN, and so on, which provide communication between electronic devices in many applications. Of course, for a long time, only optocouplers, solid-state relays, and pulse transformer were used for galvanic isolation. Of course, these products have a number of advantages, including simplicity, reliability, and low cost. But of course, in field of high-speed data transfer, they are very limited in use. It's why, as I already said, the digital isolators are the best solution for this task. But first, let's clarify why do we need galvanic isolation for signals. As you can see on this slide, this is a very good example. Here you can see warehouse logistics, which characterized by high value of automation. This is commonplace for strong magnetic fields, for transient voltages, for surge voltages, because of many power devices or power machine allocated here. For example, you can see here frequency converter, fan motor, and conveyor belt. Physical parameters like temperature, speed, voltages, and many others measured by different sensors in the field and forwarded to the main central control unit. But the problem here is that, for example, the distance between the temperature sensor of the motor and the central control unit can reach several tens of meters. It means long wires. And also that means that measured signals can be disturbed by potential differences on the line. And we definitely need to organize some isolation barrier between two devices for prevention ground potential differences. Of course, we also need it for reliable data transfer without any mistakes or errors. Another example, you can see here the frequency converter and the motor control unit. They exchange data with each other, but the problem here is that the frequency converter is located on high voltage part of the system, and the motor control unit is located on the low voltage part of the system. Again, we need to provide isolation barrier here for protection low voltage sensitive circuits from high voltage part of the system. Okay, now we can summarize main reasons for signal isolation. Again, of course, we need isolation for safety. Whenever high voltage can damage human or sensitive circuit, isolation is required. We need it for prevention ground potential differences, for minimization of common mode interferences, and of course we need it for reliable data transfer without any mistakes and errors. As you can see on this slide, the isolator electrically separate two devices, device 1 and device 2, and they can work separately without interference. It's also very important to understand that only useful signal, only data can pass through isolation barrier. And also interference and potential equalization currents are held back by the galvanic isolation. Würth Elektronik isolators are built on capacitive technology. Electric field changes with the level of charge on a capacitor plate, and the charge is proportional to the level of the signal that should be transferred. As you can see on the right side of the slide, there are two chips, and one capacitor is located on primary side, and another capacitor is located on secondary side. They are connected in series, and together they provide capacitive isolation barrier of digital isolator. Now let's clarify how data transfer is realized. As you already know, digital isolators transfer signal through isolation barrier. It's achieved by modulator to transfer high frequency signal through isolation, and receiver demodulates high frequency signal into output signals. As you can see on the right side, on the right pictures, this is input signal, this is high frequency signal through isolation barrier, and this is output signal. There is always exist some delay between input and output signal, and of course in high speed application this delay should be as small as possible. In modern world, digital isolators are very popular and used in many applications. I will specify the three biggest directions on the market. First of all, digital isolators are used in industrial automation because so many interfaces are used here. For example, RS, CAN, and SPI. Second application is different types of power supplies. For example, power supplies for server, for telecom, for solar, for lighting, and so on. And last but not least, the big application is for smart electric meters and for chargers of electric vehicles. On this slide, you can see the most popular on the market interfaces with data rate indication. First interface is RS-232 with data rate up to 1 megabit per second, but usually the data rate is much lower, less than 500 kilobit per second. And the main application here is PLC machines, printers, and modems. Second type of interface is RS-422 and RS-485 with data rate up to 10 megabit per second. Again, main application here is industrial automation, motor control, and Next type is standard CAN with data rate up to 1 megabit per second, and CAN FD, which means CAN flexible data. the CAN FD is 5 to 8 times faster than standard CAN, and of course the main application for CAN is automotive and industrial automation. Second type is I2C interface. This is quite old interface, but still very popular because simplicity and low cost of the final system. Data rate here up to 5 megabit per second, and the main application is communications between different type of sensors. And last but not least, SPI interface. This is a very fast interface with data rate up to 50 megabit per second, which provide communication between sensors, between sensor microcontrollers and memory modules. Next. On this slide, you can see isolated structure of SPI interface. On the right side, you can see some microcontroller. Sorry, on the left side, you can see some microcontroller. On the right side, you can see analog to digital converter and digital isolator in the middle. This is 4-channel digital isolator with 3-1 channel configuration. What means 3 channels have forward direction from primary side to secondary side, and 1 channel has reverse direction from secondary side to primary side. Also, you can see that this is digital isolator with integrated DC-DC converter. This solution will be very useful in application with space limitation. On the next slide, you can see isolated CAN interface. And again, on the left side, you can see some microcontroller. On the left side, you can see some microcontroller. On the right side, you can see CAN transceiver and the 2-channel digital isolators in the middle with 1-channel configuration. For this solution, as you can see, you need some external power supply based on discrete components, for example, based on isolated power modules. Very often we received a question about optocouplers and digital isolators. Where makes sense to use digital isolators and where makes sense to use optocouplers? I hope this slide will clarify this topic for you. Of course, we need to use digital isolators in high-speed data rate application. Second main reason is application with space limitation, as I already said. For example, digital isolators with integrated DC-DC converter will be very useful in applications with space limitation. And last reason, we need to use digital isolators in design when isolation of large number of channel is required. For example, for isolation 4 or 8 channel or even more. Otherwise, for example, if you need to isolate only 1 channel and data rate is not critical topic for you, please use optocoupler. I hope you already know that our portfolio has both products and digital isolators and optocouplers. Now let's discuss about our portfolio, but first I would like to specify main properties for digital isolators. First, it's data rate, what means number of bits that are transmitted per second. Second, voltage isolation, voltage level that can be applied across the isolation barrier for a period of time. Propagation delay, delay between input and output signals. Next, CMTI, or common mode transient immunity, is maximum possible rate of rise or fall of the common mode voltage between 2 isolated circuits. And last, default output, predefined state of output P when the input channel of isolator is unpowered. Our portfolio has 2 match code, CDs or CDIS, what means capacitive digital isolator standard, or digital isolators without integrated DC-DC converters. We have 2-channel digital isolators which provide isolation voltage up to 3.75 kilovolt and data rate up to 150 megabit per second. All 2-channel digital isolators are represented in SOIC 8 narrow body packages. Also, we have 4-channel digital isolators, which provide isolation up to 5,000 volts, data rate up to 150 megabit per second, and all 4-channel products are represented in SOIC 16 wide body package. And second match code, as you can see here, it's CDIP, what means capacitive digital isolator powered, or digital isolator with integrated DC-DC converter. This type of products provide isolation up to 5,000 volts, data rate up to 100 megabit per second, and all products are represented in SOIC 16 wide body package. Also, we are going to extend our portfolio soon. I hope it happens this month. We are going to have 2-channel digital isolators without integrated DC-DC converter, but in wider package, in SOIC 8 wide body. It helps us to upgrade, to increase isolation voltage up to 5,000 volts. When we speak about digital isolators, we always speak about safety. We speak about protection. This is a very important topic. It's why certification is very important topic for digital isolators. We have 2 certificates, UL and VDE. For according UL 1577, our digital isolators in SOIC 8 narrow body package provide isolation up to 3.75 volt RMS per 60 seconds and 5 kilovolt RMS per 60 seconds for SOIC 16 wide body package. Also, we have another certificate. This is IEC 60747-17, or in Germany VDE 0884-17. This is the most modern applicable standard. This standard allows to use our digital isolators in the most safety critical application. According to this standard, our digital isolators in SOIC 16 wide body package provide reinforced isolation, and for SOIC and digital isolators in SOIC 8 narrow body package provide basic isolation. What difference between basic and reinforced isolation I will explain on the next slide. As you know, on the market exist a few types of isolation level. The main of them is functional, basic, and reinforced isolation. Functional isolation provides only necessary isolation for the correct operation of the system and doesn't protect against electric shock. Basic isolation provides, in addition to the functional isolation, a protection against electric shock. And compared to an isolator providing basic isolation, an isolator providing reinforced isolation has greater requirements on its test voltage. But what means greater requirements? You can see on this table. As I already said, our digital isolator in SOIC 8 narrow body package provide basic isolation, and products in SOIC 16 wide body provide reinforced isolation. For basic isolation, maximum surge isolation voltage is 5,000 volt peak, and for reinforced isolation it is 7,000 volt peak. And also you can see that the test voltage for certification for reinforced isolation, it's almost 2 times higher than for basic isolation. You can compare. For reinforced isolation, it's 11.3 kilovolt, and for basic isolation, it's 6.5 kilovolt. Also, very important to know about failure rate over lifetime differences. For basic isolation, it's 1000 part per million, and for reinforced isolation, this is only 1 part per million. VDE standard doesn't specify any requirements for creepage and clearance distance. I mean, doesn't specify shortest distance between input and output terminals, but test isolation voltage and clearance and creepage distance have strong connection. As you can see here, as you can see on this small table, clearance and creepage distance for SOIC 16 wide body package, which provides reinforced isolation, is 2 times higher, is 2 times longer than for SOIC 8 narrow body package, which provide basic isolation. All our certificates you can download from VDE website. Please use this link. And please use our certificate number, which you can find in this presentation, or you can find in our datasheet. The same you can do for UL certificate, but in this case you have to register on UL website. Okay. What else we have except, of course, digital isolators? What we have, which design tools we have for support you. Of course, you can download data sheets for each digital isolators from our website. Also, you can see that you can find many models, for example, for Altium, for Cadence, for Eagle, and also a lot of CAD files. And you can see here, this is the symbol for our Red Expert. This is our online platform based on real measurement for component selection. And for digital isolators, you can find many useful information here. For example, about EMC conditions, about recommendation for EMC filters, also about typical applications, thermal and timing diagrams. Also on our website you can find a lot of information about a lot of recommendations for different applications, for example, for main filters, for power supply, for DC filters. But of course, for digital isolator, it will be more useful this section with different data lines. If we go inside, you can see the most popular interfaces on the market. For example, USB, CAN, RS, I2C, SPI, LVDS, Ethernet. We already implemented information about our digital isolators for CAN, RS-232, for RS-485, and RS-422 interfaces. For example, if you go inside for isolated CAN interface, you could find not only information about recommended digital isolator, and also if you click on this red square or this or that, you also will find our recommendation for common mode line filters, for TVS diodes, for ESD suppressor, for connectors, for capacitors, for quartz crystal, and many other recommended components, which you also can find in our portfolio, in Würth Elektronik portfolio. For 4-channel digital isolator with integrated DC-DC converter, we also offer 6 evaluation boards for each part number. I mean, in total, 6 evaluation boards for each part number. Supply voltage for this board is 3.15 to 5.5 volt, and output voltage is selectable, 3.3 or 5 volt. The data rate for this board is up to 100 megabit per second. Also, you can see here the place for input filter, and for signal sources you can use header pins, or for example each mounted SMA connectors, but SMA connectors are optional and must be ordered separately if necessary. Also, for our EVBs, we offer quick start guide where you can find all necessary information for quick evaluation. For example, information about main features, about schematic, and about BOM. What else we have? Few months ago, we released a new articles about digital isolators, where again you can find very useful information about application, about main functions of isolators, about different types of isolation technique. You can find detailed explanation of the inner structure of the digital isolator, and of course example for different applications. Also, if you have any technical questions, I mean about MC filter, about thermal design, about layout, if you have problem with your board, please contact our tech support hotline, and we will be glad to answer your questions. If you have some questions about pricing, about stock availability, about lead time, please contact our BDM team, and you will find answer on your question. It was my last slide. Thank you so much for your attention. Yeah, and I will be glad to answer your question now. Thank you.
So, yeah, thank you, Artem, for the interesting presentation. Now we'll come to your questions. Before we start with the Q&A session, I will share the handout from the presentation today. So, now you can download it on the right side. Then, I would say, we can start with the first question. What is the topology for integrated DC-DC converter?
The main topology, and only one topology for integrated DC-DC converter, is full bridge. Yes, and you can find you can find detailed information inside datasheet for our CDIP match code for capacitive digital capacitive digital isolators powered. Yeah, you can find it. It's full bridge.
Okay, thank you. Then, next question. Why did Würth Elektronik choose the VDI for the digital isolators?
As I already explained during the presentation, the VDI standard is the most modern applicable standard, and which allows to use our digital isolators in the most safety critical applications. Yeah, I think it was the main reason.
Mm-hmm. Okay, thank you. Then, next question. Does the digital isolators have similar response to con mode and differential mode signal noise?
Oh, it's a good question, but I mean quite complicated. The main stuff here is that digital isolator, how to say, blocking all interference from on one side and another side, and only useful signal or data can go through through isolation barrier. Please contact us and send email for us if you have more details. Yes, we will be glad to answer you. Yeah.
Thank you. Okay, then I would say we are finished with our session. I see no more question. One more question, yeah. Then, last question. What isolator do you recommend it for I2C protocol?
Yeah.
Since the CDA line is
Bidirectional.
Bidirectional.
Okay,
sorry. Bidirectional.
You know, usually I would like to say that now we have in our portfolio only standard digital isolators. Quite often, or the most common solution for I2C interface, it will be some specific digital isolators with bidirectional channels. But you also can use our standard digital isolators, but for I2C interface, you will need some external circuit. Yeah, again, it's not simple question. Please contact us and we will send you our recommendation and a schematic for how to use standard digital isolators in I2C interface.
Okay, thank you. Then I would say we are finished. When you have any more questions, you can write into the chat and then Artem will answer you via email in the next days. So now, thank you for your attention. Thank you, Artem, for your presentation.
Yeah, thank you so much.
And yeah, hopefully we see you on our next webinar. And now I would say thank you and goodbye.